Today we'll show you how to balance charge a lithium-ion battery pack using solar panels. Unless your lithium-ion battery pack is 1S and it runs at 4.2 volts, you don't need to balance charge it. But any lithium-ion battery pack that is 2S or more, meaning there are 2 or more cells in series, you will need to balance charge it. It's not optional, it's absolutely required. I looked on the internet for a solar charge controller for lithium-ion batteries, but I couldn't find any. The only thing I found is this thing here. It is a solar charge controller for 12 volt lithium-ion. It charges a 3S lithium-ion at 11.1 volts, but it only has a positive and negative terminal. It does not have balance charge. So I can't even use this to charge my lithium-ion batteries because it doesn't have balance feature. The reason why it's so hard to find a solar charge controller for lithium-ion is because to charge a lithium-ion battery, you don't just charge it, you have to balance charge it. Because if you don't balance charge a lithium-ion battery, it will either be damaged or it will burst in flame. So for example, over here I have a 2S 2P lithium-ion battery pack. Got 2 in parallel and then 2 in series. So the maximum voltage it puts out is 8.4 volts at full charge. So I need to charge this up to 8.4 volts. And if I just connect the charger directly to the main terminal, it will charge this pack up to 8.4 volts. And it doesn't care whether or not these 2 cells are balanced. Meaning it doesn't care whether this is 4.2 volts, this is 4.2 volts, or this could be 3 volts and this could be 5.4 volts. The total should be still 8.4 volts, but this one is 3 volts, which is undercharged. This one is 5.4 volts, which is way overcharged, and it could damage this and then it probably bursts in flames. So how do you balance charge a lithium-ion battery pack using a solar panel without a solar charge controller? And the answer is very simple, and it might have been in front of you all this time. These are what I usually use to charge the lithium-ion battery packs. We got the TP456, IP5306, and TP5100. So let's take a closer look here. The TP5100 board is a little bit different. If I put in 5 volts from the solar panel, the output is only 4.2 volts. I cannot get 8.4 volts output. To get 8.4 volts output, I need to have a higher voltage input. That means I have to use a 12 volt solar panel, which puts out about 20 volts DC. And then I can use it to charge a 2S battery pack at 8.4 volts. But with the 8.4 volts output, this still doesn't have a balance charging feature, so I still have to find a way to balance charge the battery if I use this option. Let me show you the solar panels I'm going to use for this project. I've got the 5 volt panel, 5 volts, and 12 volt. These 2 5 volt panels, they put out between 5.5 to 6 volt open circuit. This 12 volt panel puts out around 20 volts open circuit. This panel is from a Garden Light, and it has a controller and an 18650 lithium-ion inside. I just removed the panel and I'm going to use for this project. This 5 volt panel is from a motion sensor security light that you put in front of the garage. Inside it has 3 1.2 volts nickel metal hydride batteries. But they still use a 5 volt solar panel, so I can still use it with lithium-ion batteries. If you don't have 5 volt panels from LED lights and such, you can make your own. Because if you look close enough, you can see this one has 10 cells, so 5 cells here, 5 more cells here. And you can make your own 5 volt solar panel from between 9 cells to 10 cells and connect them just in series, and they will put out between 5.5 to 6 volts. So here is one of the solar cells I have. Each of these will put out about half of volts. So that's why you put 10 of these in series. you will get a 5-volt solar panel. I've got my solar panel out here in the sun. Let me hook it up and I'll show you how it works. Now let's check on the voltage. Got 5.6 volt open circuit. So first up, let's try it on a TP456 board. I got a single 18650 lithium ion battery here. I've got my meter set up to measure current on milliamps. Let's plug it in. Alright, we see the LED light turns red, that means it's charging. And right now the current is 254 milliamps. So that's about a quarter of an amp. So next, let's try it on a different board. This is an IP5306. Let's plug it in. 219 milliamps. So it looks like this board is a little bit less efficient than the previous TP456 board, which runs at 254 milliamp. And finally, we got the TP5100. Let's plug it in. Wow, this one is even better than the TP456. So looks like this one is the winner at 258 milliamp charging current. This board TP5100 is capable of taking up to 20 volt DC. So I have a 12 volt solar panel here, and the open circuit voltage of this panel is about 20 volts. Let's plug in the TP5100 and see what happens. Alright, so I've got the 12 volt solar panel out in the sun. Let's check on the open circuit voltage of the 12 volt panel. Wow, 21 volts. Let's plug it in. Alright, it's working. Wow, 21 volts on the input, 4.2 volts on the output. The 12 volt solar panel is about 4 times bigger than the 5 volt solar panel, yet the output is even less than the 5 volt panels. That shows how inefficient it is to convert from 20 volts down to 4.2 volts on this side. And in fact, it's so inefficient that it keeps shutting down because it's too hot. So I have to stop and put in a heatsink, you can see here on the bottom, so that it will stay a little bit cooler. On a TP456 board, there's an option to charge a 2S lithium ion, and you can see the 2 pins right here. If you connect these 2 pins together, it will output 8.4 volts instead of 4.2 volts. So I solder a switch here so that when I turn on the switch, it will connect the 2 pins together and it will output 8.4 volts. And over here I have a 2S battery pack. It's actually a 2S2P battery pack. So the output on the main terminal is 8.4 volts when it's fully charged. And I have connected the TP5100 to my battery pack here. And right now on the solar panel output, the voltage is now 18.2 volts open circuit. And that's because my panel has been out in the sun, so it gets hot, so it gets less efficient. So that's why you see 18 volts instead of 21 volts. Let's plug it in. There we go, it's charging. 185 milliamps. So right now it's charging the battery at 8.4 volt, but the battery is not being balance charged. At the beginning of the video, I said that I would show you how to balance charge it while you're using the TP5100 in series. So here they are. I'm going to use one TP4056 and one IP5306, and you can use 2 TP456 or 2 of these. I just happen to have 2 of these ready, so I'm just gonna plug each of these in my 5 volt panel. So I have 2 more 5 volt panels available. So one of the 5 volt panels is gonna go in here, the other one will go in here, and it will charge each individual cell independently. And by using these at the same time with the TP5100, each of these will guarantee each cell will charge up to 4.2 volts each. Alright, the sun has gone down, so I have to change my plan. I have to use a power supply to power the TP5100. It's going to charge the battery at 8.4 volts. My two 5 volt solar panels are going to be powered by my halogen light bulb. Now let's turn on the light bulb. Alright, here we go. See the light on the TP4056 turns red, that means it's charging. The light on the IP5306 is blinking, that means it's charging. So these two charging boards will guarantee each cell will charge up to 4.2 volts, and then it should stop there. The TP5100 is there to charge the whole pack faster because it has more power. You don't even need this TP5100 board. You can just unplug it and you can just use the two 5 volt solar panels to power the TP456 board and IP5306 boards. So there you go, how to balance charge a lithium ion battery using just 5 volt solar panels and the charging boards. This is a 2S battery pack. If you have a 3S battery pack, you can just do the exact same thing, except that you're going to need 3 5 volt solar panels and 3 of these charging boards. And then you can do the same thing for a 4S, 5S, and there's no limits of how many batteries in series that you can charge. One word of warning though, if you run the TP5100 along with the TP456 and the IP5306, your 5 volt solar panel, if they are too small, it might be not enough to charge these cells fast enough to balance charge the cell before the TP5100 has more power and overcharge one of the cells. So to be safe, just don't use the TP5100 at all. Just use the TP456 board or the IP5306. If you need more power, just put more of these or these in parallel, and you will never run the risk of overcharging any of these cells. Let me show you how I use this in a real life scenario. This is my pet safe automatic pet feeder, and I modified the battery a while back. It has a 2S 3P battery pack and it's 8.4 volts, 9 amp power. The battery only lasts for about a week, so I have to plug in and charge it every week. I'm going to plug in my 5 volt solar panels and these charging boards so that the units will run indefinitely and I don't have to plug in and charge it anymore. Here's the balance charging cable that goes directly to the battery, and I'm going to use this cable to plug in the solar panel to charge the battery. The balance charging cable comes with this connector here that plugs right into it. So I'm going to use this connector to make XT60 connectors so that I can plug in the charging board. So let me show you how I make this connector. So this is the balance cable, that's the connector. So I saw the two XT60 connectors on it. The positive terminal is this wire here, and then in the middle we got the series connection and then the main negative terminal. For the first connector, the positive terminal is here and the negative terminal is a series connection. That's the first connector. The second connector is the opposite. The positive terminal for the second connector is the series connection, because on the battery, that's a positive, that's a series connection, that's the second cell, and on the second cell the series connection is a positive terminal. So that is this wire here, which is the positive wire for the second connector. It goes to the series connection, and then finally the negative wire for this connector is the main negative terminal, which is here. So here's how I connect everything together. The balance cable goes out to this connector here, and then we got two XT60 connectors, and then these are connected to the TP456 board and IP5306 board, and then from there this and this connector will go out to the two solar panels. Here we go, I've got everything ready. Let's plug it in. We've got a voltmeter on this side and an amp meter on this side. So we started at 6.97 volts. 6.98 now, and the light turns on, so it's charging at 150 milliamp. Let's plug in the second panel. You see the IP5306 board, lights blinking, that means it's charging. So there you have it, how to balance charge a lithium ion battery without a charge controller. And all you need is 5-volt solar panels and the TP456 board or the IP5306 boards. And these boards are really cheap, only about $1 each. The charging current is a little bit low, but this is from just one solar panel. If I add the other solar panel, it's gonna be double the current. And I can always use a bigger solar panel if I need more power. But for me, at this rate, it should be enough to run this unit indefinitely without having to plug it in and charge the battery. And if you need more power, you can always add more of these boards in parallel or add more solar panel in parallel to increase the current. So for example here, this one is the TP456 board that I connect 3 of them in parallel. So the output for one board is 1 amp, but with 3 of these in parallel, I can get 3 amps out of this. So I can use this along with a bigger solar panel to charge a bigger size battery. And check that out, it's getting up to 7 volts right now. And that's all I have for now, folks. Thanks for watching, and we'll see you next time.